Okay, so if you're watching this video, you probably heard me refer to it elsewhere in some of the other videos. This really is a big topic, and if there's anything I could give you, just any trick you could have as a tutor, this would be the guy right here. This is perhaps the most amazing thing you can use when you're helping other people. What happens is that as they're going through, as the people coming through are working these problems out, they have a hard time understanding what to do with the powers. They really get tripped up, and a lot of times you'll see that they like having rules. They like knowing a hard set of rules, preferably all condensed into one thing, and that's what this is that's what this guy is right here. It's called the math chain. All that it is the order of operations. And when you look at it, it tells you what to do with the powers every single time. So I'm going to start by just writing down the math chain. I'll start at the bottom of the chain, which is the lowest thing we can visualize in mathematics, and that is doing nothing to a problem. If I have 3, I just have 3. That's it. I'm not doing anything. The 3 it has nothing happening to it. And above that is the next thing we can visualize regarding mathematics, and that's increasing or decreasing. And really, those are our two options. I can do nothing, or I can make it bigger or smaller. So I can take 3, I can add something else to it, I can subtract something to it, and it changes the number. But really, those are my two options. So everything up above this point is just a repeated form of addition or a repeated form of subtraction. So here we go. When we're looking at this, let's say we want to know, well, what is fast addition? We're going to call that multiplication. Meaning if I have 3 groups of 2, I could rewrite that to be what I just said. 3 groups of 2. 1, 2, 3 of them. And if you were to multiply those, you may have forgotten this concept because you're so good at memorizing these, you know that's what the answer is. But what this really translates it to is 2 plus 2 plus 2, meaning 2 added to itself 3 times. Gives me the same thing, right? And since subtraction is an inverse of addition, then division must be an inverse of multiplication. In other words, division, in a sense, is a fast form of subtraction. And here's how the process works. Let's say I have 21. When I divide it by 7, I want to know how many times do I have to remove 7 before I'm below 7. Well, let's count that. There would be 1 removal, which would give me the 14 there. Another removal, which would give me the 7. I'm still above 7, which means I can subtract 1 more. There's the third removal, meaning I had to remove it a total of 3 times. So the shortcut says 21 divided by 7. Well, that turns into 3 by the time we're done. Okay, so what we've established so far is that multiplication and division, those are fast forms of, let me say that again, multiplication and division are fast forms of addition and subtraction. Going up the chain, the next thing that we encounter would be powers and roots, respectively. So when we're looking at powers, powers are just a fast form of multiplication. For example, if I have 3 to the 3rd power, that means 3 times its, let's make that 4. 3 to the 4th power, that means 3 times itself 4 times. Once, twice, 3 times, 4 times, right? So this we could simplify. That would give me a 9, that would give me another 9. You can multiply those, get 81. But that's what a power is. It's nothing more than a fast form of multiplication, and multiplication is a fast form of addition, right? When I look at the roots, this one's actually harder to do, so I'm not going to do it in this video, but in a sense, roots are a fast form of division, which is also a fast form of subtraction. And if I were to throw parentheses on top of this, check this out. I've got parentheses, exponents, multiplication, division, addition, subtraction, and you're done. Oh hey, that's the order of operations, just rearranged in this form. And so this is just a little thing that I call the math chain. It's the order of operations neglecting parentheses. Parentheses just say, yeah, I'm aware of all that stuff, but please do that stuff in parentheses first. So when we're looking at this, you may be thinking, yeah, that's all right, but what does this have to do with understanding what to do with powers? Well, the rule that once I lay down the math chain, explaining it like I did just there, the rule that I give the people coming in is I'll say, whatever you're currently doing, go one step lower in the math chain, and that will tell you what to do with powers every time. Just a little side note there, notice how I slowed down, really gave it some emphasis there. When you're tutoring people, if you ever encounter an important idea, stop. You'd be surprised how much dead silence will catch their attention. Let's go ahead and test it out and just see and make sure that rule works. So, let's say I have 3x squared and I want to add 5x squared. Well, we know through practice that I could just add the coefficients and keep whatever the variable is. And you can see here that the rule is true. Here I was adding. And since I was adding right here, I should go one step lower, which says do nothing with the powers. Notice that the 2 stayed the same throughout the whole process. And the same thing is true with subtraction. If I were subtracting those, my power remains unchanged throughout the whole process. So you can see through addition and subtraction, you should do nothing with the powers. That also implies that the powers have to match in the beginning if you're going to do nothing. Otherwise, which one would you keep? So, let's test that with multiplication. What if I have x to the third times x squared? Looking at this, a lot of times I like to expand it. This turns into x times x times x. This turns into an x times x. And if I were to count them all together, I would have 1, 2, 3, 4, 5, which I can recondense to say x to the 5th power, meaning x times itself 5 times. Notice that this is a multiplication, which means I should go one step lower in the math chain. I should add my powers. It should be x to the 3 plus 2 power, which I can simplify to x to the 5th power. Notice how I've lined up my chain here. I've got increasing things on the left side, decreasing things on the right side. And the reason for this is so that they're just lined up on top of each other. You can go from multiplication straight down to addition. So let's try it now with division. Let's see what happens when we're dividing. So looking at these, if I have x to the 4th over x squared, a lot of times I'll expand it. There's 1, 2, 3, 4 over 1, 2. And when I line them up this way, you can see that the first 2 cancel, and that leaves me with an x times an x, which is x squared. Notice that since I was dividing, if I go one step lower, that's subtracting. I should subtract my powers. And you always go from whichever one has more. So I start at the 4 and I'm going to subtract 2. If that was the other way around, if that was an x squared on top and an x to the 4th, I would start underneath and still subtract 2 and write my answer on the bottom part of the fraction. But sticking with what we had in the beginning, I would go, well, since I'm dividing here, one step lower says I should subtract my powers. So it should simplify to x to the 4 minus 2 power, which becomes x squared. Next up in the math chain is the powers step. What if I have a power to a power? Meaning, what about x squared to the 3rd power? Again, I like to expand that. X squared, that transforms into an x times an x. But I want to take that quantity and multiply it by itself 3 times. There's once, twice, 3 times. Now if I count them up, 1, 2, 3, 4, 5, 6, that becomes x to the 6th power. Notice, since I'm at a power step, I'm raising it to some power. What do I do with the powers? One step lower. I should multiply them. This transforms to x to the 2 times 3 power, which becomes x to the 6th power. It's kind of neat how this whole thing works out. Okay, and we'll wrap it all up with the root stage. And a lot of times I'll pick extreme numbers here so that they don't try and do some strange process when they should be able, by this point, to recognize the pattern and go from there. So I'm going to take the 50th root of x to the 100th power. Now, I could expand this. It would take me a while, and then I would have to match them up looking for sets of 50, but we can apply the shortcut. Since I'm at the root stage, I should go one step lower and divide my powers. And whenever you're over here, you always divide from the inside to the outside, meaning it should be x to the 100 divided by 50 power. And that simplifies to x squared. Just as a little proof, let's say I want the 4th root of x to the 8th. Well, I can expand that to say the 4th root, meaning sets of 4 of x times itself 8 times. Once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Okay, just want to be sure I had the right numbers there. So I'm looking for sets of 4. There's one set, 2, 3, 4. There's another set, and I can see I have 2 sets that I can pull out with nothing left over, meaning I would have a set of x and another set of x would turn into that. So this is the matching in a nutshell. And you'll find that the more you play with the matching, the more it's just a beautiful rule you can always come back to. And so I like to share that with the people coming in. I'll take just a little bit of time, lay down the whole process, explain that everything is compounded, and if they have trouble remembering it, just go, oh, throw parentheses on top and you've got the order of operations. Parentheses, exponents, multiply, divide, add, subtract, you're done.